Okay, hi there guys. I'm going to make a short video here about this homework assignment that we did that involved using the z-score and your probability, your z-chart or z-table to calculate probabilities. First off, just to emphasize, the z-score is kind of at the foundation for all of this stuff, and it's very easy to calculate. All three of these numbers will be given to you in every problem, so it's simply a matter of just kind of doing this little calculation here. The score, or the value, minus the mean. Take that and divide it by the standard deviation, and that's your z-score. That's where a lot of these problems will start. Okay, so I'm going to do a few problems out of this thing here. I'm going to go in kind of reverse order for problem number 3, which is about a swimmer named Amy who specializes in the backstroke. Her mean time as she goes through her practice is 39.7 seconds. For one of these races, and she has a standard deviation of 2.3 seconds. So there you go. There's your mean, there's your standard deviation, and now we're going to deal with a few different scores. The first one is the very last one in this problem set that I'm going to do, because it's kind of the easiest one. In this case, the question is, what's the probability this Amy's time in her next race is less than 36 seconds? So we'll find the z-score for 36 seconds. There's our score. 36 minus 39.7 over 2.3 gives us negative 1.61. That's our z-score. All right, that's the z-score for 36 seconds. Now we're going to find the probability that her next race is less than this. And that, my friends, is exactly the number that shows up on the chart. So it's a negative z-score, so you use your negative z-score side of the chart, and you come down in this column to a negative 1.61 is right here. It's the second column over, right? 0.01 right there. So we find this number right here, 0.0537. That's the number in the chart. That represents the probability of the scores being to the left of that, this shaded area to the left of that z-score, okay? That shaded area here, that's what these numbers in the chart represent. So that's exactly what this question is asking. So all we had to do is find that number in the chart, and it's a 5.37% chance. 0.0537 means 5.37%. You bring the decimal point over 2 times. All right? So that's the answer for that, 5.37% chance that her next race will be less than 36 seconds. Let's do another one, slightly more difficult. Part D, where they're asking what is the probability that her next race will be more than 45 seconds. Okay, well there's our new score. We're going to find the z-score for 45 seconds. Do the same thing though, score minus the mean over 2.3, the standard deviation. We get a positive z-score this time of 2.30. When you check that number out on your chart, on your positive z-score chart, all right, 2.30 is right there. 0.9893, if that'll come into focus for you. And so that's the probability that the scores will be less than that, but that's not what this question is asking. Nope, we want what's the probability that it'll be more than that. Well, no big deal. You take your probability and you subtract it from 100%. That's the area to the right. Remember, the probability given in the chart is the area to the left. But if you want the area to the right, just subtract it from 100%, because the whole thing is 100%. So, there we go. 100% minus 98.93 is a very slim 1.07% chance that her next race will be more than 45 seconds. The hardest kind of question in this type of situation to ask, to answer, is what's the probability that a score will be in between two values? So the very first problem they ask is like that. And they ask, what's the probability that her next race is between 37 and 44 seconds? Well, we got to find the z-score for each of those, all right? So again, score minus the mean over standard deviation. Score minus the mean over standard deviation for 37 and 44 seconds. We get a negative 1.17 for the first time of 37 seconds, and we get a positive 1.87 for the 44-second time. When we look those numbers up on the chart, our negative z-score gives us a 12.10% chance. And that, again, is to the left. The 1.87 gives us a very high probability of 96.93%. Well, all you have to do, folks, when you're finding in between the percentage in between two scores is subtract these probabilities. So 96.93 minus 12.1 is 84.83, and that's our answer, 84.83% chance that our next race will be between 37 and 44 seconds. I'm going to do another one like that with a little graph there to help you out understand. So the next one I'm going to do, and the last one I'm going to do on this is this problem right here for number 4. And this is one about the car tires. And in the car tire problem, number 3, they ask, okay, well, they tell you that the mean, that's this little Greek symbol here, is 51,200 miles. That's the mean lifetime of this particular brand of tires, is 51,200 miles. The standard deviation for that data set is 8,200. In this question, they're asking, what is the probability that if you pick a tire from this brand, that it will last between 10,000 miles, within 10,000 miles of the mean? That word within means on either side, okay? So 10,000 miles of the mean means 10,000 less than or 10,000 more than the mean. So there's our mean right in the middle, and you go 10,000 either side of it, so now you're within 10,000 miles of the mean. It's a 20,000 mile span, but 10,000 miles either side of the mean. So we'll find the z-score for each one of these numbers, okay? Again, score minus the mean divided by the standard deviation gives us our z-score, and we get negative 1.22 for 41,000, and we get positive 1.22 for 61,000. When again we look on our chart, this negative z-score here gives us a value of 11.12%, and the positive one gives us 88.88%. And subtracting them, we just get this number here. That's our value. Let me just show you on the chart again what that means. Our negative z-score right here at negative 1.22, the probability was 11.2%. That's this area over here to the left of this z-score underneath the normal curve. 11.22%. The other one, positive 1.2, gave us a score of 88%. That's all of this area, including out there on the tail, is 88.88%. Well, we want the area in between. So all we have to do is take our 88, which is everything here to the left of this, and subtract all of this stuff, because we don't want that. We just want all of this. So that's why you can do the subtraction. It's really pretty simple. Okay, so we take our big number minus our small number and we get our probability. Okay, that's enough for this one. Stay tuned for the next video about the statistics review document. Okay, bye-bye.